Hi, I'm Hussein Kazal from the Business Development Team at Nuage Networks. We have recently announced two cloud reference architectures that include several of our strategic partners, and in the next 20 minutes I will walk you through a demonstration using these architectures. The Nuage VSP is a virtual overlay network solution designed with scale, performance, and flexibility in mind. The solution connects virtual and physical data center assets and is a multi-tenant, multi-data center solution. It has three elements: the VSD, Virtualized Services Directory, the VSC, the Virtualized Services Controller, and the VRS, the Virtual Router and Switch. At the top, the VSD is the management plane and is where network and security policies are defined and maintained. It has a northbound RESTful API and can simultaneously support multiple CMS instances in all flavors: OpenStack, CloudStack, as well as VMware vCenter. The VSC is the control plane and is built using the mature, robust Alcatel-Lucent 7x50 service router, which is installed in service provider networks around the world. For large deployments, multiple VSCs can be federated using MPBGP. The VSC can also appear with any PE router and exchange router information. The VRS is an enhanced Open vSwitch with support for distributed routing and uses VXLAN or GRE tunnels for data transport. It can also act as a gateway for non-virtualized assets. We have also completed integrations with top-of-rack switches from Arista, HP, and Cumulus. In this demonstration, we have deployed two instances of OpenStack, one using Red Hat's OSP 6 and the other is using Canonical's Ubuntu Juno release. The first architecture utilizes Red Hat's OpenStack distribution OSP 6, infoblox for IP address management, F5 for load balancing, and Palo Alto networks for firewall services. At the core, the Nuage VSP will provide network services through a Neutron plugin. The demo has two subnets, an external subnet with one client and an internal subnet with two servers and another client. As the demo progresses, we will step through the insertion of an F5 virtual big IP load balancer and then a Palo Alto Networks VM series firewall. Next is the Nuage VSD user interface, showing Tenant 1 as the Red Hat OpenStack instance and Tenant 2 as the Canonical OpenStack instance. After deploying the OpenStack instance, which includes a controller and several compute nodes, we have deployed infoblox DDI, which provides the IP address management functionality including DHCP and DNS. As mentioned before, the setup includes two networks, an external network and an internal one with two servers and a client on the internal network and a client on the external. We now move to the horizon view and can see a router and two networks, an internal and external one with two servers and two clients. This is the Nuage VSD network view, and you will see the exact same topology with two servers. These are the vPorts of those servers, and then two clients connected to two subnets, an internal one and an external one. We move to the infoblox grid view to confirm that the networks and the addresses that have been assigned came through the infoblox DHCP server. You will also see an additional network, which is an underlay management network. That is not part of the demo. It's just in the underlay to get access to the graphical user interface of these appliances. We go back to the Nuage VSD view, and this is a demonstration of the policy management to allow traffic to flow between networks. We are currently allowing traffic to flow between the external network and the internal network so that we can run a test. As you can see, anything in the IP packet header can be used to specify a rule to forward or drop. We are now creating an egress policy that will allow all traffic to flow back from the internal network to the external network. This is the test, and we are on the external client, and we will run a ping to server 1. This is a direct connectivity between the internal and external network. We will later insert a firewall and a load balancer, but for now you can see that the ping was successful between the external client and the internal servers, and now we are on the internal client to run a test, a ping test to connect to server 2. And once again, that is successful. Next, we will go through the steps to insert an F5 Big IP load balancer into that setup. We will then create a redirection target and configure a VIP on that redirection target. First, we'll show you the deployment of the F5 Big IP on OpenStack with two interfaces, one on the management network and the other on the internal subnet. What you don't see here is the configuration of the pools and the members in the big F5 Big IP. This is the horizons view showing that the attachment of the load balancer onto the internal network, and the Nuage VSD showing the same. There is an additional interface on the internal subnet, and that is of the F5 Big IP. We will now create a redirection target and configure a VIP on that redirection target and associate with the F5 Big IP vPort. You can see that the redirection target has been attached, and we will go through the test. The first is running an iPerf from the external client to the VIP on the F5 Big IP. And you can see that the traffic is flowing. Next, we'll run another iPerf test from the internal client to the VIP on the F5 Big IP. And you can see that traffic has doubled. We will now insert the Palo Alto Networks virtual firewall into the path from the external network to the internal network. The Palo Alto Network virtual firewall has been deployed through OpenStack with two interfaces, one on the external network and one on the internal network, and one for management. We will then show you the horizon of the attachment of that virtual firewall to both networks. And in the Nuage VSD, you can see that there are two additional vPorts have been added, one on the internal network and one on the external network, both belonging to the Palo Alto Networks virtual firewall. We also have to create a redirection target for each interface on the Palo Alto Networks firewall, one for internal and one for external. And you can see the attachment. And now we will set up forwarding rules to forward traffic from the external subnet to the internal subnet and redirect that to the external interface of the Palo Alto Networks virtual firewall. And we will set up another rule to redirect all traffic from the internal network to the external through the Palo Alto Networks firewall. Now the most important part is synchronization between the Nuage VSD and the Palo Alto Networks firewall in terms of policy groups and the members that belong to each policy group. Initially, the policy groups internal and external were created with no members in them. And you can see that both policy groups in VSD do not have any members, and then on the dynamic address groups in the Palo Alto firewall are empty. And now we will add all of the interfaces on the internal network to the internal policy group, and we will add all of the external interfaces to the external policy group. And then we will go on the Palo Alto Networks Firewall interface and then synchronize those policies. And you can see that all of the members that we added on Nuage VSD are now visible on the Palo Alto Networks Firewall. We will now run through a test running traffic that will get denied from the external network to the internal servers, and you can see the ping was not allowed. And you can see the logs in the Palo Alto Networks Firewall showing that. We will run an iPerf test to the VIP on the F5 load balancer, which has been allowed, and you can see that the traffic was successful, and that Palo Alto network log showed that the traffic was allowed and did indeed pass. Next, we will run the same test, but from the internal client, because all of the traffic is on the internal network. You can see that the ping as well as the iPerf were all successful. This test concludes the first half of the demo, where we've successfully inserted a load balancer and a virtual firewall into the path of data and used Red Hat OpenStack distribution as well as infoblox for IP address management. The second half, we will use an OpenStack distribution by Canonical and insert an Avi Networks virtual load balancer into the path of data. As we did before, we have created a second tenant, and that is the Canonical OpenStack distribution. We used the same external internal network and the number of servers and clients as we did before. We will now go into the Ubuntu version of OpenStack and demonstrate the servers and clients in that view and match that up with the Nuage VSD view. You can see it's the same layout, 2 servers, 2 clients, and 2 networks, an internal and external network. We also have to create ingress and egress policies to allow traffic. By default, when you first bring up a system, there are no policies created. You have to create a template with these policies to allow specific traffic or any traffic. Anything in the IP header can be filtered on and a specific rule applied. We will run a test from the external client to the servers and from the internal client to the servers. And you can see that the ping was successful. We will now insert Avi Networks load balancer into the mix. Avi's solution consists of a controller and several service engines. The controllers deployed through OpenStack as well as the service engines. And then the controller will automatically make calls to OpenStack through a REST API as well as Nuage VSD through its REST API interface. You can see that in the Nuage VSD, the vPorts for the respective service engines have been created in the right network. And then the redirection target and the VIP have already been configured. Those were automatically done by the Avi controller. On the left-hand side, you will see the graphical user interface for the Avi Load Balancer, ADC. And then on the right-hand side, we will run a benchmark test from the internal client and one from the external client. You can see that the internal client's IP is shown on the Avi user interface. And this is the VIP that we have tested against. Now we will run one from the external client. And you can see in the logs the external client's IP address. This concludes the second part of the demo. We have successfully demonstrated the insertion of an Avi Networks ADC into the path of data using the Nuage VSP and Canonical's OpenStack distribution. The infrastructure used for this demo was based on bare metal servers from softlayer in 4 different data centers, and the Nuage VSP connected all of the different components across these different data centers. This diagram shows how the different components were deployed over the bare metal servers for the Red Hat OpenStack distribution, and this one is for the Canonical Ubuntu OpenStack distribution. Thank you for your time, and if you need additional information, please email us at info@nuagenetworks.net or visit us at www.nuagenetworks.net.